Hello, everyone. Mr. Minix, my name. Math is my game. I'm joined by my favorite Algebra 2 class, my fifth period Algebra 2. And we're actually going to go over this homework. Starting with number one, it says graph this function. So if you need graph paper, or notice on the graph paper, see how there's a couple graphs down below? There's probably enough room to fit that on the first one. We'll put number 8 there too. So this is number one. Does it say f of x or does it say y? I can't see. It says f of x. Thank you. Cool. Negative 3x squared. So if I had no idea how to graph this, I'll be honest. I might say, well, I'll just hand it in tomorrow and say, I don't know how to do this. And hopefully the teacher's in a good mood. Or maybe I could use an app that I have on my Chromebook. Not Mathway, but the other one, the beautiful free graphing calculator, Desmos. Desmos. So let me go to my apps, and here's my Desmos graphing calculator. Now, we're not cheating. We're using a resource so that we can figure stuff out. The function is negative 3x to the exponent 2. So we see the graph. A couple things we should probably notice. What's the highest point on this graph? What are its coordinates? 0, 0. What's that called? Should we label that? Probably not a bad idea. So here we go. At the origin, we have the vertex. On Wednesday, there's going to be a quiz over this, and on Wednesday, you will be asked to label 4 more points. We'll start off nice and slow with this, because we're going to jump around and we're going to look at some Math Excel stuff too. So if we go back to Desmond for a minute, it'd be nice if we could come up with at least one other point that the graph clearly goes through. And I think that there's one right there. Whoop, right. Oh. Is that fair to say that it goes through 1, negative 3? Okay. So the graph also goes to the point 1, negative 3. Now, you might notice that I made that negative 3 a different color. Do you think that negative 3 has anything to do with the negative 3 that's the coefficient of x squared? Probably, yeah, and we'll find out a little bit more about that in a minute. So we also go through this point over here by symmetry, and for now, I think that's enough points. I think that's pretty good. Is everybody all right so far? Good. So now that we've got that one out of the way, I think that we could probably give number 8 a whirl. I think we could probably give number 8 a whirl. So if we try to graph number 8, we've got f of x equals 5x squared, and we're not even going to use Desmond this time. Where do we think its vertex is going to be again? 0, 0. Yeah, it's just about like the last one. So on this one, it's going to have its vertex at 0, 0 as well. Now, in number 1, we had negative 3x squared, and it went to the point 1, negative 3. If we had to take a wild guess, what's a point you think this one might go through? 1, 5. Yeah, you're right. This is going to go through 1, 5. Over 1 and up 1, 2, 3, 4, 5. So this is going to go through the point 1, 5. And by symmetry, we'll get this other point. So there we go. Now, maybe you're not for sure that that's what it looks like, so we can graph to find out for sure. So let me go back to Desmond for a second. Desmond, let me change that negative 3 to a positive 5. And let me press enter and see what happens. And let's see, does it go through the point 1, 5? Yes, it does. Good. How's everybody doing with the first couple? All right. Are there any questions? Well, now that we've got that, let's go to Math Excel. And let's see if we can't do a couple in Math Excel. In Math Excel, by the way, this is due the end of the night on the 30th. This first one, where's the vertex of this thing going to be? 0, 0, the origin. The vertex is going to be 0, 0, the origin. So I'm using my parabola tool. I'm clicking my vertex. Now, what's a point that we expect this to go through? 1, negative 8. Good. Now notice on the x-axis they go by ones, but on the y-axis they're going by eighths. So over 1 and down 8 like that. We think that's going to get it done? Check it out. Bam. Like a boss. You got to be real careful how you pronounce that. It's not B-O-S-S. It's boss. I don't know how you'd spell it, but like a boss. All right. Well, this one, what's the vertex going to be? 0, 0. So the vertex is going to be 0, 0, and then what? 1, negative 10. And let's check it like a boss. We got it. So far, so good? All right. Now, this next one is kind of like number 12. Same ideas apply, but it's a little bit different, a little bit tougher. What's the vertex going to be on number 12? The vertex is still going to be 0, 0. What's a point we expect this to go through? 1, well, it was 1 something, right? It was 1, negative 3, and then 1, 5. So this one we're expecting it to go through. Do we see what we're going for on this one? What's this other point that it's going to go through? It's going to be 1 what? It's okay to have fractions. They're part of life. This is varsity math. Negative 4/9. Yeah, it's going to go through 1, negative 4/9. Now, you might not know how much negative 4/9 is, so let's think about it. 4 divided by 8 is a half, right? So 4 divided by 9 is a little smaller than a half. And that's probably good enough for now. So it's a little less than a half. So it's going to be a wider graph like that. But what if we had something like this in Math Excel? What if we had something like this in Math Excel? Well, we do. Check it out. In Math Excel, in number 3, we're going to have a fraction there. Oh, this is positive 4/9 instead. So where's our vertex? 0, 0. Now, it's not going to let me plot the point 1, 4/9 yet. It's not going to let me plot the point 1, 4/9 yet. I've got to commit to a point, so I'm just going to click here, and I'm going to say, you know what? Yeah, I'm going to lock that in. Look at the upper right corner of the screen. Do you see where it says 4 out of 7 complete? Watch around there, because I'm going to click this point again and watch what happens. Well, it didn't happen up there. I'm sorry. It happened down below at the bottom of the graph. Do you see what showed up? What's it say? Edit coordinates. So I do want to edit coordinates, and I want the point 1, what? 4/9. And I can't actually type in 4/9 there. 4/9. I'll submit that, and we'll check it, and there we go. How's everybody doing? Does anyone have any questions, comments, concerns, short debates about anything so far? I'd like to give a shout out to the future Mr. Minnick. I'd like to give a shout out to anybody that's watching this back. I'd like to give a shout out to whoever can figure out this number 2 here. Wow. Wow. That's not going to work. Sorry, I just made a rectangular cut and I didn't cut out what I needed. So let's try that again. So number 2 says, let's determine whether this thing has a minimum or a maximum value. Well, we have no idea what the graph looks like yet. Hopefully, we should be able to think, though, if the graph opens this way or if the graph opens this way. Can anyone tell me which way it opens and how you know? What do I got? Oh, you're looking on Desmond. Well, that's okay. So which way does this one open? This one opens up. There's something that tells us that it opens up. What tells us that it opens up are all the numbers in front of, whoa, I didn't mean to cover those up. I meant to highlight them. All the numbers that are multiplying x squared out. Would that be positive or negative if we were to figure that out, that number that's going to multiply x squared? It would be positive, right? Because it's positive, that's why this opens up. So does this have a minimum or a maximum value? So what they're saying is now we know it opens up. Is it a min or is it a max? This one is going to be a minimum. What's its maximum? Well, it doesn't have one because it goes clear up to infinity. That's it. That's it. If you couldn't tell that because you couldn't recognize the a value, well, maybe you could have gone to Desmond. If we go to Desmond, just to verify that, here's a quarter times the quantity, was it 2x minus 15, the quantity squared, and then there's plus something at the end, right? Plus 158, just 150. Now we don't see it, but that's okay. We can actually zoom out, and we could zoom out, and we could zoom out, and we could zoom out, and there we could see that it's opening up. So that's what we got. So there it is. That graph opens up, and it does have a minimum. Does it ask us to find the minimum? Okay. Doesn't ask us to find it. So there we go. That's that one. Number 3, we're going to skip over for meow. I did say meow. We're going to skip that one right now. Number 4, I'll bet we can figure out. When does the graph of a quadratic function have a minimum value? When the graph opens up. And what happens when the graph opens up? It goes up to infinity. So let's say when the graph opens up. But there's something else about it. I don't know if you remember this from last week. We graphed the parent function like this. Remember doing that? Watch the number that shows up in front of x squared. So that number is like 0.027, 0.99, 2 point something. What can we say about it? It's going to have a minimum when that thing's what? Positive. Yeah. What's that thing called? What variable did we represent it with? Not an x, an a. So when the graph opens up, when a is greater than 0 or when a is positive, okay? So that's how we're going to go ahead and answer number 4, when the a is positive. We doing all right so far? So let's take a quick look at number 5. It says, is this function quadratic? Explain. Number 5, is this quadratic? Explain. I'll bet that somebody knows. I'm not allowed to bet in school, but I'll bet that somebody knows the answer to that. Let's just go back to this graph for a second. Remember, we were like Madagascar. I like to move it, move it. Let's move this around. Watch that number that's multiplying x squared. I can't make it 0. Come on. I can get it close to 0. What do we got? If we graph y equals x squared, it looks like this. If we graph y equals 1/8 x squared, it looks like this. If we graph y equals negative 1/4 x squared, the graph looks like this. The hint, the clue is right here. Is this going to be quadratic? I'm hearing no. Why not? because it's hard to explain, but if the a value is 0, then it's going to wipe out the x, and we'll just have y equals a number. And what kind of line is that? It's one that goes straight across. It's a horizontal line. Good. Yeah. So is this quadratic? No. Since a is 0, we would have y equals a number, which would give us a horizontal line. Okay. Since the a value is 0, we would just end up simplified with y equals some number, and that's a horizontal line, and horizontal lines are not quadratic. It would be a function. It'd pass the vertical line test, but it wouldn't be quadratic. That reminds me of something funny. My nieces wrote a rap about me called King Quadratic. He's so mathematic. I'll have to record it. I'm going to make it my ringtone. So far, so good? All right. Well, we don't want to give all these away, but 6 is a good one to look at. 6 is a good one to look at. I said we're going to have to skip over 3 for a minute, but 6 is a good one to look at. So they want to know the difference between x plus 6, the quantity squared, and x minus 6 plus 7, the quantity squared. So let me try something here. So we got x plus 6, the quantity squared. And then we got x minus 6, the quantity squared. And then plus 7 on the end. Plus 7. There we go. I think something got screwed up there. Something got screwed. Oh, yeah. The quantity squared, and then plus 7 over here on the side. There we go. Whoa! I don't even see it. If I don't see it, but I grab something, how can I get it to fit the window? Let me go to menu and let me try zoom. Which zoom would make sense? Nothing happens if I zoom out. Let's try again. Let's try zooming. What would make everything fit in the window? Thank you. Zoom fit would be a good idea, huh? Maybe that's not the best one. You guys said zoom out. Let's try that. I'm going to undo what I just did. Let's try zooming out. Menu, window, zoom. Let's zoom out. I got to tell it where to zoom out from. I want to zoom out from up here. Let's try that again. Menu, window, zoom out. Zoom out from up here. There we go. Okay. How do those graphs differ? Their vertexes, their vertices are in different places. Is that fair to say? Are the graphs the same shape, though? What if we were to take this one and drag it over here? Are the graphs the same shape? Okay. So the question says, describe the differences between them. So what are the differences? Well, yeah, sure. The location of their vertex. So if we talk about this one, where is its vertex? Its vertex is on this graph. It's the well, we got to be real careful when we do this. So we're looking at the blue one, and where's its vertex at? It's at negative 6, 0. Good, yeah. So its vertex is at negative 6, 0. And then if we look at the other one, its vertex is going to be at 6, 7. Everybody cool with that? That's kind of weird. What's weird? Well, let me get my highlighter and reflect on a couple things. This will help us tomorrow figure some stuff out. If I look in the parentheses here, see how I have an x plus 6 there, and then this is a minus 6? Doesn't that seem, yeah. What do you got? Yeah, the why about this one, it's kind of weird. You'd have to kind of like calculate the minimum, but is it fair enough to say that the x coordinate of the vertex is the opposite of what we would expect it to be? Okay, okay. And then what about the y coordinate of the vertex? Here it's +7. Does that seem okay? And then over here, there's nothing being added, and that one's 0. Does that one seem okay? All right, fair enough. Um, so I think we might be ready to try another Math Excel one. Let's see. Let's see. Maybe we're ready to try this last one here. Let's fire up some parentheses. Inside the parentheses, I know I need an x. Now, it'd be nice if I knew the vertex here. What's the vertex? 1, 5. Well, let's go back a minute. When the equation was x minus 6 a quantity squared plus 7, the vertex was at 6, 7. Okay? So let's think about that. So what are we going to have inside the parentheses here? A -1. Yeah, you would think it'd be a +1, but a -1, I'm pretty sure that's going to get it done. The quantity squared, and then what? A +5. Good. Now in number 7, there's one thing that's missing. In number 6, we kind of get lucky on this one by accident. Yeah. The a value, the number in front of the x squared. If we look at this, and we were to see how far over from the vertex we go and how far up we go, that's going to kind of help us. But on this one, we kind of luck out on that one. Okay, we kind of luck out on that one. How's everybody doing? Okay. Good. So this last one, this number 7. Let's try this one. Inside the parentheses, what are we going to have? X. We would think it'd be x minus 3, but that part's the opposite of what we think. So it's going to be x plus 3, the quantity squared. And then oh no, and then a +6 on the end. And then a +6 on the end. But then from the vertex, we go over 1 unit and down 2. From the vertex, we go over 1 unit and down 2. So what that tells me is that I need a number in front, a -2. And we'll talk more about that one on tomorrow. Everybody all right so far? Boy, we're trucking right along. I'm glad. All right. Well, I think that leaves us on number 16. 16, we got to figure out the vertex. We got plenty of room on our graph paper. 16. Where's our vertex going to be in this one? The vertex is going to be where? Somebody said it. 2, 0. Good. So there's my vertex. Vertex 2, 0. And then it's going to be, oh, how'd you know that? All right, so somebody came up with a point of 0, 4, which is good. This actually goes to the point 0, 4. If we were to come up with that one, and we actually could come up with that by making a table, couldn't we? If you think about it, number 16, f of 0 would be 0 minus 2, the quantity squared. So that's going to be 4, right? So yeah. Can we use symmetry to get another point? So what would the other point be? 4, 4. Good. So we got 4, 4. Now there's one more point along this axis here that would be nice to have. So 3 something. Let's get one more point in here. 3 something. 3 something and 1 something. It's not going to be 3, 2, and 1, 2. It's going to be 3, 1, and 1, 1. Now, I want you to be real clear about this, where that 1 comes from. I want you to be real clear about where that 1 comes from? That 1 comes from the number that's sitting right in there. What is it? It's a 1, right? I know we don't see it because it's not there, but that's where that comes from. Okay? So we'll go ahead and graph this. And it says, let's describe how this was translated. So number 16, how was this translated? Was it translated to the right, to the left, to the up, to the down? From the parent function, how was it translated? What do we got? So it went to the right. How many units? 2 units. Perfect. Nice. Good. So it was translated to the right 2 units. Everybody cool with that? Well, I think we're about ready to try the next Math Excel one. The next Math Excel one, we're going to have another translation, but I don't think it's going to be, well, I don't know. Let's see. Where's the vertex of this going to be? I heard a 0 right away, and the way you should be able to recognize that it's 0 something right away is there's no parentheses. So there's no parentheses. No parentheses tells me my x-coordinate of the vertex is going to be 0. So it's going to be 0, -1 I'm hearing. The vertex is 0, -1. I like it. Now, once I get that vertex established, hopefully you realize that since the a value of this, what's the a value? 1. So the a value says, you know what? From the vertex, I'm going to go over 1, and then I'm going to go up or down however many a is. So I'm going over 1, and in this case, what am I going to do? Go up 1 or down 1? Up here or down here? What am I going to do? The a value is +1, right? So the graph's got to open up. So from the vertex, I'm going over 1 and then up 1. Doing all right? Okay, let's try. Well, how's this translated from the parent function? We got it's either 1 unit up, or it's 1 unit down, or it's across the x-axis, or it's across the y-axis. We're thinking it's translated 1 unit up. It's saying from the parent function, though. Remember the parent. It's a, yeah, it's translated 1 unit down. Translated 1 unit down. Let's try another one just like that. Where's the vertex going to be? 0, -2. And then what do I do? Pray for a miracle. Go over 1 and up or down. I'm hearing 1. Up 1 or down 1? Up 1, yeah, good. Okay. And how does this one relate to the parent function? 2 units down, good. All right. Well, I think we're moving right along with this. Is everybody cool so far? All right. Wow, look at all those questions. That's off the chain. Let's skip over 24. Let's just look at 28. We got y equals x minus 125, the quantity squared, plus 125. And they want us to identify the vertex. Now, I don't know if you've made this connection or not, but the x-coordinate of the vertex comes from a certain part of the equation, doesn't it? It comes from inside the parentheses. And I think we said that it's the opposite of what we expect it to be, right? So what's that going to be? I'm hearing 125. It is 125. The y-coordinate of the vertex comes from whatever's being added at the end. So in this case, it's that 125 that's over there. How's everybody doing so far? Now the axis of symmetry, this one's kind of tricky. It's a vertical line. It's a vertical line that goes through the vertex. Does anyone remember this from algebra? This says that vertical lines have an here's the V, here's the U, have an undefined slope. Their equation is x, and that's where the x comes from, equals some number. So the whole point of that is a vertical line's equation is x equals something, x equals something, x equals something, x equals something. So, back to number 28. They're asking us for the axis of symmetry. The axis of symmetry. It's going to be an equation that goes through the vertex. It's an equation of a vertical line that goes through the vertex. What do we got? X equals 125 is right. Now, which 125 are you referring to? The x coordinate of the vertex or the y coordinate of the vertex? Yes, and this comes from this x coordinate of the vertex. Good. Okay, so that 125 here is from the x coordinate of the vertex. Hopefully everybody is down with that. Okay? We're feeling all right? So 28 also asks us, what's the maximum or minimum value? First of all, we need to know, does it have a max or does it have a min? How do we tell? Well, we look at the number before x squared, the number before the parentheses. If it's positive, the graph opens up. If it's negative, the graph opens down. Well, what number's out front there? A 1, and 1's positive. So because that 1's positive, the graph opens up, and because the graph opens up, it has a... Because the graph opens up, is that going to... It's going to have a minimum, okay? So this one's going to have a minimum. And now we want the minimum value. Now we want the minimum value. And the minimum value here is... Now, let's be real clear about this. This minimum value of 125 is actually the y-coordinate of the vertex. That minimum value is the y-coordinate of the vertex. This problem is kind of confusing because I used 125 in both things. I apologize for that. It's not my fault, it's theirs. The domain. What's the lowest x value that this graph could take on? The lowest x value that this graph could take on. It wouldn't be a 125. Where at? The lowest x value. It would be infinity. Yeah, those arrows mean it goes on forever. If you don't believe me, check this out. Here's the cool thing about a calculator. Let me add a new graph here. So this function is the quantity of x minus 125, the quantity squared, and then plus 125. If I click Control T, I'm looking at the table, and I look at the x values in that table. I look at the x values in that table. See how far up I can go in the table? Do you think it's ever going to make me stop? The x value is negative 100. It's negative 200. It's negative 300. I can go as far as I want to. So it goes from negative infinity to infinity, and there's another way to write that using words. Does anybody know? 3 words. Using words is so this is interval notation. That's interval notation right there. There's another way to say this in words. 3 letters, 4 letters, and then however many letters that is. X can be whatever it likes. Do you guys know that song? Yeah, what do we got? Why is x 125 for the vertex? That's a good question. Remember, the x-coordinate of the vertex comes from inside the parentheses. The x-coordinate of the vertex is the opposite of what you expect it to be. Let's go back to this one here for a second. The one with the 6 and the 7 in it. Remember this one? So if we look at this one here, the x-coordinate of the vertex was actually positive 6, even though inside the group it's a minus 6. Let's go back to number 16. Look inside the parentheses. It's x minus 2, the quantity squared. Look at the x-coordinate of the vertex. It's a minus 2 in here, but the x-coordinate of the vertex is a positive 2. So maybe we need to make a note to ourselves. Note to self. Note to self. The x-coordinate of the vertex. The x-coordinate of the vertex. Isn't it always the opposite of what we think what we expect it to be? So how did we say that last week? We used two fancy words, hyphenated like that. It's the opposite of what we think. Thinking is called intuition. So this is the opposite of what we would think. Remember that? The x-coordinate of the vertex is counterintuitive. Right? We're this close to wrapping this up. We're just a minute amount of information away from wrapping this up. So here we are. We're back at, where'd we leave off? We're on this one. The domain in words. How do we say this? From negative infinity to infinity. That includes every single number that's real. All real numbers. That's what Math Excel is going to want you to say. All real numbers. That's what Math Excel is going to expect you to say for that one. All real numbers. Now this does have a minimum value, and that's going to help shape our range on this. That's going to help shape our range. Our range goes from the minimum, which is 125, all the way to infinity. But there's another way to say this. In words, we're going to say all real numbers greater than or equal to 125. Okay. So this arms us with enough information to answer the last question on Math Excel. We ready to try it? Okay. Math Excel, last one. Here we go. So what's the vertex here? We would think it's going to be -7, but it's not. It's going to be 7 something. 7 what? Yeah, notice the y-coordinate of the vertex is what we expect it to be. The x-coordinate's the one that's backwards. So far, so good? Okay. The axis of symmetry goes to the vertex. It's a vertical line whose equation is x equals, say it loud, say it proud. Somebody almost said it. X equals 7, good. Does this have a minimum or a maximum? It has a max because the a value is -1. It has a max, and the maximum value is the y-coordinate of the vertex, so it's -28. And what's the domain? The domain is always going to be the same. It's going to always be all real numbers for the domain. Okay. In the range, this one had a max, so the range is going to be all real numbers less than or equal to the max, which was -1, -28. Okay. So that's the Math Excel homework. Hopefully you'll be able to wrap that up tonight if you try it. Should be easy. So we got one more we're going to look at, and then that's it. And then that's it. Number 32. Here we go. Where's the vertex in 32? -7, -8. Good. -7, -8. Houston, we have a problem. If I go over 1 unit from the vertex, how far down should I need to go? If I go over 1 unit from the vertex, how far down should I need to go? 2? I'm hearing 2. Not 2. 3. Where's the 3 come from? The A value, right? So what I need to do from the vertex is I need to go over 1 unit and down 3. Well, that's going to put me off the graph. That's okay. So that's the best we could do on this one. There we go. That's going to be some point -6, -11, and -8, -11. And if you're not sure if those are the points, well, you could graph it and check on your calculator, huh? Are there any questions about that one? Comments? Are we done with that one? It says graph it and identify the axis of symmetry. So we're not done. The axis of symmetry is the equation of a vertical line. -7 is a part of that equation. And vertical lines in their equation have, it will be what equals? X equals -7. X equals -7. And that's it. Are there any shout outs? No love for your classmates. Shout out to who? To Callan for being beautiful. Shout out to the future Mr. Minnick. Well, it's been real. It's been fun. See you next time.
Good.